Welcome all you lovely people. In this video we'll do something fun and actually use what we have done previously to implement a game. Before we can do that, we first need to define the rules of the game. The game tree itself has three different kinds of nodes. The action nodes. That is when a player is required to pick an action, such as call, raise or fold. The chance nodes. That is when things out of the player's control happen, such as drawing a card. The terminal nodes. That is when the players either showdown or one of them folds, leading to game over. At the start of a Leduc poker game, two players both get one card each, either king, queen or jack. The deck itself has 6 cards total, meaning that it has 2 kings, 2 queens and 2 jacks. The showdown rules are that the highest pair wins and failing that the high card. You know how No Limit Hold'em has 4 streets, pre-flop, flop, turn and river. Leduc has 2. It is a limit hold'em game with a maximum of 2 raises on every street, or rounds in this case, after which the remaining player must either call or fold. Once the opposing player makes a call, the first round transitions to the second one and the second one transitions to the showdown, which is a terminal state. The game itself has almost 2000 states in its entire game tree and almost 500 visible states. It can easily be solved using tabular algorithms. Also, I forgot to mention that at the start of the game the antes are 1 chip for each player and the raise size is 2 chips on the first round and 4 chips on the last one. Here is how it is implemented. First, you will note that the hand comparison rules are implemented faithfully. Next, take a look at the game itself and you'll see that it looks quite a bit like the game tree that I sketched out. First, you'll note that it starts off with the 2 chance nodes. After that, the round 1 starts. In the round 1, it goes through the action node. A fall leads straight into the terminal node, a raise leads to it staying in round 1, and a call leads to it going through the chance node into round 2. Round 2 is similar, except a call leads to the terminal node there. In my opinion, this is a very clean implementation. The game logic is all there and it is not bogged down with the details of how, for example, the player should get the action from the UI. Or how, for example, the cards should be sampled. You might be wondering what that iLeduc interface is. It's in the shared project. If you're an experienced functional programmer, you probably understand well what that R return type is. If you aren't, you are lucky as you have a chance to learn it on something practical. Let me do a little continuation passing style tutorial here. This particular technique is all powerful and it will make a lot of what we will be doing a lot easier. First, I want to point out that if you have a parent function that takes in a continuation, that is, a function passed in through an argument whose return type is the same as its parents, then the only way to get that return type is to actually get it by calling it. Take note of how I am getting type errors in the IDE when I try to return anything but the R type. Secondly, you can get some pretty interesting results if you make the return type R a function. If you just have the continuation return an object, like a string or an integer, then that isn't particularly fancy. But if you return a function, you will be able to defer the computation. Take note of what is going on at the bottom, in the terminal window. I am sending the code snippets and observing the results in the F# interactive REPL. Continuation passing style is a really powerful tool for abstraction. Do you remember how in the previous video we were sending string lists from the server back to the client? That actually has an useful purpose here. You should be able to see how here we are accumulating messages on the game state and passing them along. In the chance nodes we don't need to ask the UI anything, so we just call the continuation. But in the action and the terminal nodes we are doing something quite more involved. We are calling a dispatch function. Going back to this, do you remember the model view update pattern? It is a similar thing. The game sends a message to the relay along with the model, which then gets passed into the web UI. Once an action gets picked by the user, the web UI sends the data back to the server, which then gets passed to the game. Using a concurrency library, I can spin the game off on its own thread and implement it that way. In fact, the Elvish library could be used for that very purpose, as it is not just made for React. You can use it for things that do not need views. If I went that way, we could have had 3 Elvish threads going, one for the client, one for the server and one for the game, each communicating with each other using message passing. If I needed to do so in the future, it would be very easy to redesign the game implementation to be like that. So because it would be easy, I instead opted for the simplest implementation possible, which is to just send the continuation directly to the relay. Let me show you the type of the message being sent to the server. It is the game model, the list of messages for the message window, a record of allowed actions, and the continuation which the relay server will run after it gets an action back. And this is most of what we need to implement the game itself. Let's give it a try. Before we finish this video, let me just show you how simple the update functions for both the front-end and the back-end servers are. The client is simple and the only state the relay on the back-end holds is the continuation. Once it gets an action from the client, it calls it and then gets rid of it. I hope you found what I've shown you in this video interesting. If you have, please like and subscribe. It takes a lot of effort to make these videos. So far we have the game, and we can even play against ourselves. This is pretty good. Using this as a basis, we can now start working on computer-controlled players. We'll start off with a random player and then bring in the counterfactual regret ones. In the following videos, you'll be able to see really just how much using the continuation passing style is gaining us, so be sure not to miss out. This was your favorite ball with a sheet on it, and I'll see you in the next video.